We present augmented data physicalization, blending dynamic data sculptures with virtual content for interactive visualization. Although data physicalizations became dynamic and interactive through technological advances, they are still predominantly used for casual applications. In this work, we thus add high-resolution virtual overlays. We combine shape-shading interfaces with augmented reality, which allows us to realize interactive data visualizations. We call this concept augmented data physicalization, for which we contribute a systematic design investigation in blending shape-shading interfaces with augmented reality. We provide a structured repertoire of essential visualization components such as axes, labels, links, or similar contextual information. We further discuss interaction techniques that facilitate direct input on the physical device, as well as remote gesture input. With these, users can explore data in sophisticated hybrid ways, such as focus and context techniques. We further demonstrate them in 3 implemented example applications. Based on these use cases, we conducted hands-on sessions with external experts, resulting in valuable feedback and insights. To demonstrate our concept, we combine a string-based mid-air display called Straight with the Microsoft HoloLens 2. We use QR code tracking for real-world alignment and WebSockets for communication. A Unity application with MRTK and UTVS creates the virtual overlays and controls the dynamic data sculpture remotely. Our first use case, called Personal Information Hub, provides valuable casual insights for users in a domestic environment. While users might recall the meaning of this abstract data sculpture, AR provides the necessary details for understanding. We show personally relevant data, for instance from a home automation environment, as virtual plots within AR. Users can assign these to the available elements on the physical interface with a drag gesture. While AR presents supplementary information, such as axes and labels on demand, the physicalization dynamically adjusts to incoming data. Apart from the physical charts, our application provides ambient notifications for messaging apps or online subscriptions. These can be assigned to the physical sculpture in a similar fashion. The user can drag a physical handle to a section of the bar to select an item, first seeing a preview and then triggering an action like showing a video or playing back music. Second, our interactive exhibit use case narrates a story about the vase of Blonoccis, an important historic pot found in Poland. We build scaled replicas of its individual shards and attach them to the physical interface so that they can be individually actuated. The AR view displays a volume visualization of the archaeological excavation site, which hides the physical shards in the beginning. Using proximity-based interaction, so by stepping closer to the exhibit, the excavation progressively unveils more parts and shows supplementary text. Once the visitor stands directly in front of the exhibit, physical actuation reconstructs the complete vase. An AR model of the vase fills the gaps between the shards to complete the historic object. Integrated magnets ensure that all parts seamlessly snap together in their final assembly position. As users focus their gaze into certain areas, we will reveal more details about the inscriptions. Our third application example is a suite of basic visualizations. For a hybrid line chart, a physical line interpolates data along a bigger virtual line. Using single-handed navigation and two-handed scaling, users can manipulate the visualization to their needs. For a hybrid bar chart, we place the physical elements on top of 3D rendered bars. Direct drag input allows users to select items, and remote gestures allow them to navigate along the x-axis. We further build a physical version of the same bar chart. It uses extensible pins, and here they are actuated according to the user scrolling left. Our scatterplots need to be hybrid, as some items can be physicalized, while for others no physical element is available. As an example of an overview and detail concept, we provide a mini-map of the scatterplot. It allows the user to manually select a visualized range using mid-air gestures. Next, we realize the hybrid version of a parallel coordinates plot. We provide 2 stacked handles per axis that allow the user to filter data with haptic feedback. Meanwhile, the chart itself is completely virtual. Our hybrid node link diagram consists of physical nodes and virtual links. As 3D charts are often impaired by occlusion problems, we make use of direct input for rearrangement. The virtual links then follow. Based on our use cases and hands-on sessions with external experts, we see great potential in combining dynamic physicalizations with dynamic AR overlays to create rich and engaging data experiences.